Hello, welcome back to the channel. In this video, we are going to cover Chapter 3 of the Principles and Practices of Commercial Construction. And Chapter 3 is dedicated to the site development and services. And as you already know, there are 16 chapters, so this is video number 3. And this is a relatively short chapter, so it is going to cover pavements, curbs and sidewalks, parking areas, stormwater um, management, and lighting and landscaping. So let's dive deeper into the site development and services. So once the site evaluation is complete, and that was in chapter 2, and drawings are finalized, services must be provided for the building or complex that is to be built. So the amount of site work will vary depending on the amount of existing infrastructure in the area to which the new construction can connect. So it's always important to check the and take advantage of the existing streets, utilities, and parking areas. And check if such utilities as sewer, water, electrical service, natural gas are available on site. So you need to locate them and understand how that is going to be used during the construction. So please always refer back to the textbook. There is a beautiful section showing the roadway right-of-way cross-section with utility line location. So that is important to understand how that is technically implemented in the drawings and how it is illustrated. So in addition to the basic utilities, most new buildings need to be wired for high-speed telecom cables such as fiber optics. And also the new buildings are being equipped with the necessary conduits for these types of services, as well as for future technology and expansion of services. So pavements. The objective of good pavement design is to build a road that supports the required design traffic loads, requires relatively little maintenance, and has a useful life over a period of 10 to 20 years. And in reality, we see that actually the lifespan is a little shorter due to some damages in weather implications. So material and construction costs, high energy costs, limited municipal budgets, and an innate inability to predict long-term traffic patterns all add to the challenge of designing and building good roads. So the following criteria should be considered for the design and construction of roadways: the expected design life of the roadway, performance criteria, traffic volumes and truck loads, materials for the roadbed and the wearing surface, the type of subgrade on which the road must be built, drainage requirements, climatic conditions, and budget restraints. So all that actually leads to the quality of the pavement. So sometimes flexible pavements actually are preferred over rigid pavements for several reasons. Lower initial cost, historically that is true. Then the self-healing properties of flexible pavements, relatively low maintenance and ease of sectional repair, good surface wearing properties, and the fact that asphalt can be easily recycled. So also what is important to understand that over 80% of the asphalt used in road construction in North America is being recycled, which is a good news, but still it's not the most sustainable way to pave the roads. We will cover sustainability a little later in this chapter. So good pavement design should consider the following, and that's according to the Ontario Hot Mix Producer Association and the National Asphalt Pavement Association. So traffic density, the condition of the subgrade, drainage requirements, environmental conditions, new asphalt technologies, and pavement maintenance and management. So the structure of a flexible pavement consists of the subgrade, subbase, and base, and the pavement wearing surface. And you can see a beautiful section here, and you can see the typical asphalt pavement structures. And you can see the compacted road bed ready for pavement. So there are a few nice images. So please always refer back to the textbook. So the wearing surface and upper structural course of the pavement is a hot mix of asphalt, cement, and well-graded, high-quality aggregate that has been well compacted to provide long-term performance. And now, actually, they start to mix it with the aggregates that are made of the recycled tires and so on. So that becomes a little more sustainable, but still that is not sustainable. That's not good for the nature. So here are a few pictures of the equipment that is used to work on the pavements, and you all, I'm sure you have seen those steel wheeled rollers and other heavy duty machines. So rigid pavements. Rigid pavement design is somewhat different than flexible pavement design. And most particularly, the wearing surface also serves as the strongest layer in the pavement section. So another section here. So please take a look how that is structured. So then when we look at the pavement overlays, an asphalt pavement overlay can be applied to an existing asphalt pavement once the wearing surface original pavement has reached the end of its design life. And normally at this stage of the pavement life cycle, some remediation of the surface must be done before the overlay can be applied. A prime coat of hot liquid asphalt is applied to the existing asphalt pavement as a bonding agent. And the milled asphalt can be reheated, mixed with the new asphalt, and reused. So when we talk about curbs and sidewalks, there are a few things to remember. So curbs help to designate the edges of streets and serve as part of the gutter to drain the runoff from the street. And sidewalks are required for pedestrian safety and provide access to the building itself. So although curb shapes and sizes vary from one jurisdiction to another, there are two basic types of curbs, such as regular curbs. Usually they rise 6 inches above the pavement surface and are about 12 inches in total height, and low rise or mountable curbs. And they are different, and you can see actually the pictures here with the section and with the street application. So please take a look at that. And there's a concrete curb forming machine as well. And concrete sidewalks are usually 4 inches in thickness and can vary in width depending on the anticipated pedestrian traffic. The base for the sidewalk is well compacted earth or well compacted granular fill depending on the soil conditions in the area. And the sidewalks normally are 5 feet or in width or wider. Crack control joints are placed at 3 to 5 feet spacing. Expansion joints are provided at intervals of 30 feet or less and where sidewalks bear against buildings or other fixed structures. Typically at 2500 psi, air entrained concrete is used to provide a weather-resistant surface. The surface finish is a light broom finish and the edges are smooth with an edging tool. And you can see a picture of that here. So for curb ramps at intersections, sidewalks are sloped down to street level, provided a transition from the sidewalk to street elevation. And at vehicle crossings, the sidewalk thickness may be increased to 6 inches and reinforcing steel in the form of welded wire mesh may be added. So again, there are a few nice images here. Please refer to them. So when we talk about parking areas, the construction of a parking lot follows the same basic rules as those outlined for roadways, although traffic loads do not play as important a part in the design. For parking areas that are not subjected to heavy loads, factors such as subgrade conditions, ease of construction, and aging of the hot mix asphalt are more of a concern than traffic loads. So the supporting subgrade must be free of organic material, and portions that are susceptible to freeze-thaw action should be remediated with a stable granular fill. The whole area must be graded to provide the necessary drainage and covered with a base of granular material at least 6 inches thick and compacted to a value of 98% of the modified Proctor. Again, there is a nice picture and the section, so please refer to that. And a concrete mix topping known as pervious concrete has similar properties to that of porous asphalt pavement, and that is also allows water to seep through it and into the underlying subgrade. So let's talk about storm drainage and sanitary sewers and the stormwater management. So many years ago, stormwater runoff was directed into the sanitary sewer system. This was called a combined sewer system. As more stringent environmental laws evolved for the treatment of sewage, combining the two systems created extremely large volumes of liquid sewage during periods of heavy rain. In many instances, these large volumes overloaded the sewage treatment plant, resulting in untreated sewage being diverted into rivers, lakes, and oceans. So in the past 40 to 50 years, systems have been separate, with sanitary sewage directed to treatment plants and stormwater runoff directed to retention or detention facilities to accommodate the runoff. So what is important to remember here, there are a few different materials used for piping, such as PVC, precast concrete, or ABS pipes. And there are illustrations of that. You can see that, and I'm sure you've seen them throughout the cities. So stormwater management, that is a critically important aspect now. And US Green Building Council program for LEED, or Leadership in Energy and Environmental Design, actually they have developed guidelines for lessening the effects of construction on the environment. So you can look it up, just go to the usgbc.org and you can check information there. You can get all the scorecard and see how that actually works. And now some of them are actually prerequisites, like construction activity, pollution prevention, and so on. So, and also the EPA has determined 2 detrimental properties of post-construction runoff that produce considerable impact on the environment. The first one is the increase of harmful pollutants in the runoff as it passes over the area affected by development. And the second one is the increase in the rate and quantity of runoff that occurs during a storm. So this increase has a negative impact on the receiving body of water, the natural body of water, resulting in the stream banks and flooding, which in turn can cause property damage and affect aquatic life. So please review all the requirements, the EPA guidelines, and other things before actually planning your storm water runoff. And we are moving to the lighting and landscaping. So street lighting standards vary from one area to another depending on the needs of the community. So street lighting is important for the urban environment, and that provides better visibility for drivers, as well as visibility and added protection for pedestrians. So in good lighting also aids law enforcement, and that is needed for the security purposes. So, but as you know, excessive lighting produce light pollution, and actually that is the street lighting that is used to light the streets and cities and bridges and highways. That is being countered by redesigning light fixtures to direct the light in a downward direction rather than in all directions. So special lenses such as aeroscreen lenses provide extra control of upward light in areas where it might become a problem, such as in the vicinity of the airports, for example. And yes, again, you can refer back to the lead that actually has other restrictions, so that will prevent the light pollution. And that wraps up our chapter 3. Thank you so much for watching. I will see you in chapter 4.